OSU is not an aim trainer, it does not help you with your aim, and I am dubious that it even helps with your reaction time. That said, our sponsor for this video, Valorant, actually does.
But the two-dimensional aim just doesn't translate very well to shooters. Very enjoyable, but for the purpose of improving your aim, not really that effective.
And people thought the most controversial thing you can say in this community is that OSU is a waste of time. Well, let this be a fucking lesson. I will never make anything more controversial than this if I tried. Okay, I spent a long fucking time on this. And schizophrenia medication. I might be schizo, but the math is correct, okay? It is real. So let's set this straight. Is OSU really not an aim trainer? I will talk about how to normalize sensitivities, how you can compare them, 2D versus 3D aim, mouse movements, and the conclusion that you probably won't expect. So to start, since it's the most used Twitch command in any OSU stream as well as every shooter stream, let's talk about sensitivity. For 3D games, normalized sensitivities for comparisons is very easy. All you really need to do is multiply in-game sense with your DPI and boom, you got your eDPI. This also applies to OSU. Just take your mouse DPI, multiply with whatever. Okay, thank you Steam. Just take your mouse DPI, multiply it with your OSU sensitivity slider, and you have the eDPI for OSU. And the most common one I saw across mouse players is an eDPI of about 1000. And very often that being by having just 1000 DPI at 1.0 speed. But here is the problem. It's very easy to compare eDPIs, but only as long as you stay in the same game. If you want to transfer your Overwatch sensitivity to Valorant sensitivity, knowing your eDPI in Overwatch won't be enough. Games use very different measurements for sensitivity, and you need a different converter online to convert them. But because these converters exist, obviously it is possible, since you can always measure just how much you need to move your mouse to do a certain movement, and then adjust the other game's sensitivity until it just feels the same. It's really simple, honestly. Measure down the distance that you have to move your mouse to do a whole 360, write it down as centimeters per 360. Then adjust the other game's sensitivity until it is the same amount of centimeters for 360. And then you can just compare the two sensitivities, and from there on you can just calculate every other sensitivity. And that is nice and all, but I don't believe I can do a 360 in OSU yet. Maybe it's in OSU laser mode at some point, I don't know. So for now we have to find the 2D equivalent to a centimeter per 360 measurement. When doing a 360 you might spin in a circle, but your mouse really is just going from left to right, just going from one side to the other side. So if you do that same movement, we reach the border of our monitor. Instead of moving your camera from left to right until you do a 360, you can move your mouse from left to right until you hit both borders of your screen. And I do think that you can use that as a sort of centimeter per width type scale. So to figure out what the centimeter per width for 1000 DPI is, it's really some simple math. Okay, I'll demonstrate this here. So excuse my handwriting, but DPI just stands for distance per inch. The E stands for effective, and the distance is measured in pixels. So also sometimes people call this PPI. You might see that sometimes on the internet. I'm gonna use the metric system for this. So, and technically, instead of calling distance per inch, you could maybe call it distance per 2.54 centimeters. Never mind. So 1000 pixels per inch. So to find out how many inches you need to move your mouse on a full HD monitor, you divide 1920 by 1000, and this gives you 1.92 inches for one side, from one side to side through from left to right. So now that's our universal sensitivity for now, and converted to centimeters is this number. But does that even make sense to consider OSU as an aim trainer? We haven't talked about that at all yet. It's a whole dimension difference, right? It's only 2D, 2 dimensions, whereas 3D games are in 3 dimensions. If you look at my beautiful illustration of a 1-2 jump, you can see the visual cue on the monitor, followed by the expected input of the mouse movement. And on the other side, you see the visual cue of 2 targets on Ascend mid in Valorant, followed by the expected mouse movement for that scenario. And now you might notice it's both the same. To go from one point on the screen to a different one, it's the same movement, just the distance is different. So you might have noticed the mouse is moving in the third dimension at all for Valorant, because a mousepad is a two-dimensional surface. But it's not just that, your monitor itself is a two-dimensional surface. The so-called third dimension in these 3D games is just a very smart little optical illusion to trick your little monkey brain into thinking there's a world in your screen. So if you really think about it, the only difference in 2D versus 3D games is where the camera lies. When also the camera is fixed on the whole screen, in Valorant it's fixed on your cursor. And also you move the cursor to the circle. In Valorant it's more like you pull the enemy into your cursor. And assuming you are blindfolded and you don't have the visual stimuli on your screen aiding you, and you just know that if you're on a target, the next target is 2 centimeters to the right of your current place on the mousepad. If you do that movement in both games, it'll both work if the target in-game is that far away. So to finally debunk the argument that Osu is 2D and Valorant is a 3D environment, all you need to consider is how you're aiming at something. It looks different on both screens because of the fixed camera, but our movements aren't dependent on that. We only see the difference in perspective after you've already done the flick, so the perspective doesn't influence your aim, because you only see it as a post effect. Similar to how in Osu it is a rhythm game, but you don't react to the music, because the music happens as you are reacting. It's more, that would be like reacting to the future, which I guess you could do if you memorize the song, like on rhythmically dense maps like Sputnik, for example. But if you use the visual instead, it really doesn't change the fact. Similar to how hidden doesn't really do that much at high ARs, because you see it and it disappearing doesn't matter because you can't even react to it disappearing. You don't have enough time to realize it disappeared on high ARs, which is why it doesn't affect us that much. So basically 2D versus 3D is an optical illusion, but a grey one. So now we've got like three out of the 4 puzzle pieces already. We have the universal sense in both 2D and 3D environments and the mouse movement. And now it's just a matter of how do we actually convert our Osu sense to our Valorant sense then. And that is the entire reason I am making this video. I've known that the movements are the same for a while, but I didn't think it would be good enough to make a video just entirely on that to prove it. Because, I mean, yeah, I prove it, but people just won't be convinced just by saying, I mean, 2D is 2D. The 3D is just an optical illusion. People won't be convinced by that alone, right? So that's why I did this whole video, to present to you the last puzzle piece, how to convert your Osu sensitivity into your Valorant sensitivity. So welcome to the final chapter. We again think of the 3D space as a 2D space. Now if you place 2 targets on the far left side and far right side, it is the same distance on our monitor as the edges of the monitor itself. If we then ignore the camera movement, we just need a distance moved by the mouse to hit 2 targets to line up with the distance moved the mouse to go from the monitor's left to right edge. Or even better put, your Osu FOV is now 103 degrees, as that is Valorant's FOV. The only difference is that your camera doesn't follow the crosshair. A better way to demonstrate this is Roblox actually. So in Roblox there is a... Wait, that's a horrible fucking analogy. So in Roblox, there's like, I've only played Roblox a little bit, so I wouldn't know if there's like more games like that, but probably is. So there's this game where you're like playing from third-person perspective, and it's like you have a gun, so you have a pistol, right? And it goes like pew. So you have a gun and you're in Roblox, so it is a shooter game, and there's like these little zombie guys coming at you. It's like waves of those, and you shoot at them. But there's like 2 ways of shooting at them. One is the regular, you have a crosshair and you move your camera to them, or like as I said earlier, you move them to your cursor, right? You move the enemies to your crosshair, you pull them in, it's magnetic. When Osu, your cursor is the thing going to them. So in Roblox, there's this game where you can either do this, or if you just use your mouse, you can move the crosshair onto the target, onto the target with your cursor. So either you move your camera, or you're in the mouse mode where pressing right click moves your camera. But if you just like use your mouse regularly, you move your crosshair or like on your screen. So in this game, clearly, there's both of these versions, and there has to be a sensitivity which makes both of these movements equal because they're both fundamentally on a 2D space. So that's the theory on how like brute force it. That is slow and tedious, and I'm not gonna do that. So I thought I can use math to figure out how to calculate it. So here's how it works. So Valorant's FOV is 103, and our inches per width are 1.92. That's how many inches we need to move to go from left to right side of our screen, right? I'll use metric from now on because it makes it a lot easier, okay? So we have centimeters per width of the monitor, which is 4.8 centimeters. And because we know the width of a monitor now is the same as the FOV in the game, because that's what we see on both games. So one edge from one edge to the different edge in OSU is just like the screen. It's 1020 pixels. Well, in Valorant it's also 1020 pixels, but in game it's a FOV of 103 degrees. So we can just say that in OSU it's not centimeter per width, it's now centimeter per 103 degrees, because that is the width. So we replaced the width with 103. So that's now our that's our centimeters per 103 degrees. But since we need centimeters per 360, we multiply 4.88 with roughly 3.5, and what we get is a centimeter per 360 of 3.5 times 4.8 is 17.07 centimeters. This is talking about a 1000 DPI in OSU. If you use 1000 EDPI in OSU, it should be the same as 17 centimeters per 360. And don't click off yet, because I still haven't settled if OSU is an aim trainer yet. You can convert your sensitivity, but does that mean OSU is an aim trainer? But first, I have a small table of OSU sensitivities here. So if you have an EDPI of 17.07 centimeters, here's how you can do that in Valorant. If you had 400 DPI, you put 1.9, 800 DPI, you put 0.96, 1000 DPI is 0.765, and at 600 DPI it's 1.276 sensitivity in Valorant, respectively, for each DPI. But now I hear you say, here's the extra chapter, I don't play Valorant. Valorant is cringe. I play Overwatch 2. Ignoring the fucking irony of that sentence, I also have a calculation for how you can convert that to like other games when your other game has a different FOV. So you have inches per 360s equals your monitor's width divided by the DPI you have, multiplied by 360 degrees divided by the FOV of your respective game, which in Overwatch is also 103 degrees actually, unless you lower it manually. So that's how you get your inches per 360, and to get the centimeters per 360 you just multiply it by 2.54. And so to finally answer the question of the whole video, is OSU an aim trainer? And is this video sponsored by an easy to use reliable VPN service with military? Well, the answer to both is no, the fuck it is not. And to now answer why playing OSU still isn't going to make the next 10s, or you're playing glorified fucking grid shot.